This theorem is based on inequalities. Okay, if you take two real numbers which is greater than product of two real numbers is greater than to 0, then two possibilities occur. Okay, first is a is greater than to 0 and b is also greater than to 0. It is an obvious possibility. Okay, as you take -1, you take 1 and 1. Product of 2 1 is greater than to 0 and 1 is greater than to 0, then the product of 2, it is always greater than to 0. That is it is implied. But second one is not an obvious. A is less than to 0 and b is also less than to 0, then ab is greater than 0. How it is possible? Let a is equals to -1 and b is equals to -1. Then the product of ab is equals to -1 into -1, which is equals to 1. That is greater than to 0. So second holds. Okay, now let the determinant the set. How to find the set? By applying this theorem. X square, you have to find out x square plus x is greater than 2. Then after solving this, it is x plus 2 x minus 1 is greater than to 0. Now from the theorem, first either x plus 2, a is greater than to 0, b is greater than to 0, then x is greater than to -2 and x is greater than to 1. Okay, the second case is x plus 2 is less than to 0, either x minus 1 is less than to 0, then x is less than to -2 and x is less than to 1. First case is satisfied only for the set b. We have to satisfy x is for b. Okay, so first case satisfied only if the set b conditions, only if x is greater than to 1, right? Why? X is greater than to 1, then it will possible, because if you take 1 minus 1, then it is 0, it makes it 0. So always x is greater than to 1. X is greater than to -2, it is not be possible. Okay, then for second case, it is also, you can consider by the set conditions only if x is less than to -2, right? So we conclude that the first and second union of two sets becomes b. We have to find b. What is x is in between this? So x is in R is such that x is greater than to 1, and union of x is in R is such that x is less than to -2. That is the set.